let's study the probe again. We made the resistance matrix here, 50 ohm, 9 meg and 1 meg. And we study the influence of C1 at the port. And we have a time constant then. Here we have a time constant. We measure 10 pf parallel on 9 meg in parallel with 1 meg and 50 ohm. And this is about 9 microseconds. Then we are going to remove this capacitor and go to the second port. And the second port, there is 90 pf connected to 1 meg in parallel with 9 meg and 50 ohm in series. And this gives us a 81 microseconds. So we then say this is the dominant pole of the network because the time constant is larger than the other time constant. Now realize that if this is the dominant pole, then for the second pole, the impedance of the capacitor will be much lower than the impedance of the resistor seen by the capacitor, which means that you could say that the capacitor shorts the port. So that's what we are going to do. We found the dominant pole, that is P1 now, and then we are going to short this port, and we have this. And then we place the 10 pf there and find another time constant, which is 500 picoseconds. And now we have a second pole, let's say 318 megahertz. And you see it is a slightly different result than we had before when we calculated the eigenvalues. I remember it was something like 1700 hertz. So we make a little error, and this error is because there is charge going from one capacitor to another capacitor. Basically, we should also look at the off-diagonal elements, but this is not so easy for estimation. Then you really need to solve equations. So this is the method that we are doing. We are taking the capacitors and inductors out. In this case, the capacitors. We're taking the capacitors out. Then we build up the resistor network. We then one by one replace the capacitors, look for the time constant with the largest value. That is what we call the dominant pole. Short this pole and do this again for the next one, and again and again and again and again. So if you have 10 capacitors, you make 10 different circuits, and every time there's one more shorted. This is the way it works.